Hello everyone, welcome to my class math lesson with Miss Kenny. This is video part 2. After learning about geometric sequences, now we are going to learn about special number sequences. Let's find out what special number sequences are. The first is square numbers. These are the first 7 square numbers: 1, 4, 9, 16, 25, 36, 49, and so on. Okay, you need to recognize this immediately, that these are square numbers. Okay, if I write down the square numbers in index forms like this: 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, I can formulate that the nth term for the sequence of square numbers, the nth term is n squared. I am squaring the position number because this is the first position, the second position, the third position, the fourth position, the fifth position, and so on. The second special number sequence is cube numbers. See, 1, 8, 27, 64, 125, 216. These are cube numbers. So when I write down the cube numbers in index forms like this: 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, I can formulate the nth term by cubing the position term like this, because this is the first position, second position, third position, fourth position, fifth position, sixth position, and so on. Okay. And then next, quadratic sequences. What is that? When you see a sequence, the first thing you need to do is to check between two consecutive terms whether there is a common difference or a common ratio. But if the sequence has no common difference or common ratio, we need to find the difference. Not the common difference, but just the difference. 4 to become 7, you need to add 3. 7 to become 12, you need to add 5, and so on, like this. This is the first difference. Okay, the first difference, can you see, is making a sequence also. So let's find the second difference now. Okay, now the second difference. Okay, this is an even number, 2. Okay, and this also a common, 2 is also the common difference of the sequence here. The sequence has second degree. It means has second difference here. If the sequence has a second degree, it means we are going to use the square numbers. So I'm going to use table so I can see the position and the terms together. Put the square numbers under the terms. Okay, like this. For the first term is the under the first term is 1, under the second term is 4, and so on. And then find the difference between the term and the square number. 4 minus 1, 3. 7 minus 4 is 3. 12 minus 9 is 3. So there is a common difference here. Since there is a common difference, we can just write down the nth term as n squared plus 3, like that. Okay, let's see. What about these cubic sequences? When you see a sequence, the first thing you need to do is to check between two consecutive terms. Okay, whether there is a common difference or a common ratio. If the sequence has no common difference or common ratio, find the difference. 0 to become 7 is 7. 7 to become 26 add 19, like that, and so on. And then again, find the second difference now. Okay, still there is no common difference. Find again the third difference. Now you have a common difference, which is 6. So this sequence has third degree. So we are going to use cube numbers. Okay, let me use table so I can see both the position and the term. Under the terms, write down the cube numbers. Okay, according to the position. And then find the difference. 0 minus 1 is minus 1, 7 minus 8 is minus 1, and so on. So we have a common difference here, minus 1. So to find the nth term, we just subtract 1 from the cube of the position number, like this, as simple as that. This is an example of cubic sequence. Okay, next example is the sequence of this triangle numbers. Why we call this triangle numbers? Because when we put this number like this dot as a dot, we can create triangles. The pattern of triangles like this. So when you see a sequence, your first thing you need to do is to check between two consecutive terms whether there is a common difference or a common ratio. If the sequence has no common difference or common ratio, let's find the difference. Okay, let's see the difference here. The first difference is making a sequence, so we need to find the second difference. Now, the second difference here is a common difference. Plus 1, plus 1, plus 1, plus 1, plus 1. Okay, so this is a quadratic sequence. But what's special about this quadratic sequence? See the last difference, the second difference here is 1. So you need to use the half of perfect square numbers, half. Why half? Because the last difference is 1. You need to divide by 2. Okay. Like this. The second square number is 4. If you divide by 2, you get 2. You then find the difference. And the difference here is not a common difference. So the difference here is making a sequence. So we can find the common difference. The common difference is half. So this is sequence inside sequence, so to say. Since this is sequence inside sequence, we need to find the nth term of the sequence inside here. So we use the arithmetic sequence, the nth term for the arithmetic sequence here. The first term plus the multiple of d. The first term is half, the difference is half. Okay, like this, and then we simplify the final answer. The final answer for this sequence is half n. So we need to put this together. So the nth term for these triangle numbers, the nth term, the formula is half n squared plus half n. So it looks difficult, but it is good practice to be aware of key sequences and to always check whether the sequence you are looking at is a variation of one of those. The key sequences include this one: square numbers, cube numbers, power of 2, and triangle numbers, the last that we learned today. Okay, that's it for today. Thank you for watching Math Lesson with Miss Kenny.